Where were we?
Yeah, when were we? 2 weeks ago. Um, I've got minor updates. I sent pull requests to RPM project to include the fix for the tests. We one test that emitted warnings in the debug mode, but it didn't emit warnings in the mm, standard mode. So I adjusted the test to work in both cases, and that was accepted.
Ooh,
And
nice.
there was another pull request changing this custom my print to print. Uh,
Oh, so you just went through all of that?
yes,
Ah, you're now a regular RPM committer,
very regular. One commit every week.
right? Nice,
um,
nice, nice.
yeah.
Yes.
So
Ooh.
that was pretty much find and replace and verify it's replaced in all the places.
Okay, interesting. So if it was CPython, I would say don't do that. Just define my print as print and don't make a diff. Anyway, so do I
Last
have any notes about how to run the tests here? I know we did that last time.
So we were working in the underscore build directory, or maybe in your case,
Ah,
yes. And then we were running
make check.
make check.
Ah, right. Underscore build, that's the one.
Yes. And we stopped here, but I made an advance towards that. It's in my fork. You can add it as a remote.
Ooh.
Oh,
Oh, my custom command only works in root directory.
so yeah, there is my multi-phase branch to distinguish from your multi-phase in it.
Nice.
And that one moves the issue a bit further. We were talking about the Cossinell patch, but it didn't apply at the end of our last meetup. So I made this one applied, but then another commit which we tried to cherry pick did not apply.
Okay. So rewrite the usage of moved objects. Right, so that just adds mod state to everything that failed
Yes.
before.
Yes, I basically repeated your steps
Nice.
successfully.
Yeah,
And
well,
then
I don't remember my steps, so just bear with me. Okay, next up.
That's okay. And then there was the commit that did not apply cleanly. That's the one you also had it in your old work. And it required a few changes regarding where to put the change. So
So let me open my fork. That was
ABI free.
3, and And the commit is define and initialize. So we add the definition here, use it instead of the boolean for the importer, and allocated, set it to zeros.
Yes.
And then the rest of the code will set the individual stuff in it, right?
Yes.
What state parameter error is blah blah blah. That should set all of it. Nice. And the struct is defined like that. We have mod state
applied cleanly.
Wonder if that compiles.
That should compile and should run tests, and the one test should fail. This is our test. This is the test that is trying to print out IDs of the objects, the errors.
Nice. Okay, this looks like a new warning. All right, nice, great.
That comes from the other commit. I see it. Because I was looking at the resulting code after applying that patch, and it seemed to me like we've got PyInit RPM like declaration, or how do you call it? And then just a line underneath, there was the full definition.
Right. So this is about the W missing prototypes warning, which I think just became default in Fedora recently. So that's a bit interesting. Let me put that back because we will want to put it back.
Okay.
That's rpm module.py.c. So
feel free to just drop that comment of mine.
This is something that you would usually have in a header. It's a function function declaration, right? This is a function declaration. This is the function definition. This one would normally go inside a header like these HDR from object, right? That's the thing. And then other C files would include this header, and they would get the definition. So now the compiler knows that this function returns an integer and takes these two arguments, right? Historically, this was not required. So historically, when C was just starting out, functions took an integer or took a variable number of arguments and returned integers if you didn't declare them otherwise, which is really horrible behavior. Right, so if you just didn't specify the types at all, they default to int. And that still happens because C is backwards compatible. So if you omit the header and just use the function from another C file, you would get the wrong types, right? So that's why there's this warning, which is now turned on by default, to require the prototypes, right? Now the compiler doesn't know the difference between headers and C files. So if it sees static, that means the function is only available in the current file, so that doesn't need a declaration. But if it's not static, it's probably used in some other file. So with this warning, you do need a declaration. Now, of course, here We don't have a header to put this in because this function will be called by Python, and we don't compile Python with our extension. So we satisfy this by just putting the header here. That's probably something to put in a comment, right?
It sounds so.
Just put it on one line.
There's a type, yeah.
Okay. Okay, so and the other warnings were for fortify source, which I guess don't apply for us. That's compiler settings. So fhardened enables some safety compilation options, make the program harder to hack, make it do something unexpected, and apparently it needs optimizations to be turned on, but hopefully we build in debug mode so it's easier to run a debugger. That's fine.
Here I've got a question, not regarding hardened flags, but the original commit, the one that needed tweaking to the mod state this one, defining initialization of mod state. Originally, the code to initialize it was in this function we just were looking at, the prototype, the init RPM. And that function currently just does the module initialization. It doesn't do anything else.
Right.
In our current code, we ripped everything from it.
That's good.
And we moved this module initialized flag and this exception to another function, which is where I put the mod state in instead. So it's like module init.
So it's correct now. Yeah. This was an oversight on my part, and it wasn't that important before. But the reason it's correct is because the PyNet function can either return a module def, or it can return an already initialized module object. And in the latter case, such a module is not compatible with subinterpreters. Right? And Python cannot distinguish between these two cases before importing the module. So for safety, what Python does now is it calls the init function in the main interpreter first to see what it returns. And if it returns a PyModule def, then it goes back to the interpreter that's importing, actually importing the module, and I guess calls it again. and finishes importing the module, right?
Mhm.
So if we had the error, where is it? We still have that. If we have this mod state error,
It was here. We got rid of it.
Well, it's still necessary. Anyway, if we had this error in the init function, you could only import the module in the main interpreter because the logic would run there first, right? So this function isn't called in the check. It's just pretty deep in arcane knowledge, but there it is.
Yay! And I had to replace the return value in case of an error because null was deemed not a valid one.
Yeah. All right, then.
Yeah, we got rid of this import error thing in the committee demonstrated the issue, and I was not sure whether I should like bring it back or just roll with it.
Oh, demonstrate the issue.
So I decided to roll with it, but
there's this test.
Maybe it's premature.
Well, eventually we'll remove. Well, eventually we'll not need this. And this is test. Okay. Yeah, that's the one. Okay. Great.
So the comment belongs to that removed part of the import error that was in the demonstrated the issue. I just removed it because it made no sense here and it only increased my confusion.
Right, yeah. Yeah, that should go to that commit.
We can drop that commit, right? It was just like a cleanup to...
No, it's fine. I'll follow it up with this one. Nicer to have that comment. Alright, so what's next?
Oh, GC callbacks. I'll pour some more tea and be back in a minute.
GC callbacks. Alright, so now we have a module state. Where is it? Now we have this mod state variable which is still global, but now it refers to malloc structure. Where's the free for this malloc?
Never happens.
Never happens. So before, without this demonstrating the issue, the malloc could only happen once, right? So the entire process would lose this much memory, which is fine. I mean, memory leaks are only dangerous if you leak continuously, right? So assuming we had that guard in place, this is fine. But of course, if we want to make it possible to have multiple RPM modules, then we need to free this malloc because it no longer is only called once. So what we need to do is we need to go to this module def and see there's this mfree currently set to null, and that's a function called when the module is getting discarded, right? I see we have traverse and clear already. When did that happen? Is that in
It
this?
has been here. We did not add it.
Oh, it's in the main branch already.
Yes, it's like this error was a global variable, so we added just mod state to it.
Huh.
I'm pretty sure it's in the main branch. Master branch.
Interesting. Yeah. It's the file name here. Python RPM module.
Yep, it's in the master branch. RPM module traverse and RPM module clear.
Oh.
6 months ago.
Oh, so it's pretty old. Oh, I know. So, haha. Okay. So these types, all of these types, were static. I don't know if they're still static. Well, they're not because we use specs. But before they were static, which means the whole type structure was in the source code. Have you seen a Python static type before? Oh, let's look at one in CPython. CPython
Yeah.
source. Object. So, here's a Python type object. It's a C structure that defines stuff like its name and its wrapper function and its iteration and all of the behavior of the type, right?
Mm-hmm.
So this is dict, right?
Mm-hmm.
It's static, which means there can only be one dict type in the entire Python process. It's shared between all the interpreters,
Mm-hmm.
which is not what we want in a module, because this type needs some module specific state, right?
Mm-hmm.
So this used to be static even in so this used to be static in Python 2, but PyRPM error is created at runtime when the module is initialized with PyErr new exception. It's really hard to make static subclasses of exceptions in extension code. It's possible, but it's I mean, there's nice API to make it at runtime, right? So this makes the type, and even in Python 2, apparently it was done this way, right? So
Okay.
this exception was created at runtime. It's if you have multiple module objects, each one has its own exception type, and so it needs to, well, PyErr new exception is basically a malloc, like creates the memory, so that needs to be freed somewhere, and it's freed here in PyModule clear. And by the way, this is much of the reason, or this is one of the main reasons why all of the other ones need to be created at runtime as well, because they probably need to access this exception type to raise it, and for that they need to go through their module object, because the exception is stored on the module object, and for that they need their module object, and there can be multiple, so all of these need to be created at runtime and registered on the module object as well. Right? But we kind of have a template now for how the freeing will work. There is a traverse function which is used by Python's garbage collector to get an idea of which object is referencing which other object. So every Python type and also every module should have a traverse function that calls pyvisit for everything that's referenced by that module or that object. Then we have a clear, which should do the same thing with pyclear. That does a decref on this and sets it to null. Right, so that's pretty widely used Python API function or macro. Like release a reference and set this object to null, so it can't be used again. And there's also free, which will usually do the same thing as clear. And the difference is the garbage collector first calls clear on the objects objects that are no longer needed to break the references, and that helps it resolve reference cycles. Right, so it calls clears, that's hopefully sets some things to null, makes the graph of the objects referencing each other a bit easier to work with, and then it'll call free and actually deallocate memory. Right? At that point there are not that many references between the objects, which means there are not that many pointers that could point to memory that's being deallocated. That's always bad. Right? So we first try to break up the relationships and after that call free. Now this is a bit more complicated because at least for normal types the interpreter sometimes calls clear and sometimes not, and sometimes it calls traverse and sometimes not, and it'll always call free. So we do want to define the free function as well, and usually we want to make it the same as this clear one.
So when there was the global error, PyRPM error, why wasn't there a free function?
I think that's a mistake, an oversight.
Okay.
Also, I think modules are a bit better behaved and maybe they just call it clear. Maybe clear is called every time in modules. I'm not sure how this works. Maybe it just happened to be called. I don't want to answer that question definitely because we'd spend the rest of the hour doing that, and probably next week as well. So now I think we're ready to update, to apply this commit, right? So what this does is updates traverse to visit everything. It updates clear to call clear on everything, and it updates free to basically do the same thing as clear. And this is unfortunately written in a slightly complicated way, so let me do it manually first. So first of all, this will call visit. This will call visit on all the types that are in the module. struct. Hopefully that's understandable. Hopefully it's all of them. Where is the where's the header for this? Where's this mod state defined? This isn't it. RPM system, right? RPM system.h. Yeah, that's the one.
Yeah.
Okay, it's all of them. Nothing got added in the meantime. Right, now we do the same thing for clear. So we do this and change all the visit to clear. Right? And we also define free. Why can't I just copy from GitHub and stick that pointer in here? Right, and RPM module free does the same thing as RPM module clear, except it doesn't return anything because it's defined as void. It cannot signal an error because there's really not much you can do with an error in something that clears memory. Right? What's the problem with this code? The problem with this code is that we have a giant list of stuff that's repeated 3 times. Right? So at least we should do something like call RPM module clear here. Oh, and we get a state instead of M. Yeah, but we use mod state anyway. So instead of mod state, we could do that. But now we use mod state. I'll just use that. We know nothing looks at this M yet, so this would be fine. And now the whole list is only repeated 2 times. What could we do to only repeat it 1 time? We could define a function to be called on each of these things, and pass that function to some generic function that does the loop, basically. Except traverse is already something that can call a function, right? So this PyVisit macro, and this is pretty complicated, this PyVisit macro calls the visit function on its argument, right? So this visit proc, I don't know if that's documented, hopefully. Yeah, here it is. This visit proc is a function that takes an object and some argument and returns an int. The PyVisit macro calls the visit function with this and this argument. And if that function returns non-zero, then it returns that value, right? So pyvisit is already a generic function calling mechanism. It's not a function, it's a macro, which means this visit needs to be called visit. The name of the variable matters. Also, this arg matters. You can see how it's defined. It's a long definition. So pyvisit is defined as, well, there's this do while 0, so this only happens once. If op is not null, then it calls the visit function with op and the argument. And if the visit function returned non-zero, then that non-zero is returned. Because it's a macro, this return will return from the function where the macro is used, right? So each of this pyvisit can return from the traverse.
Okay.
Right, so let's rewrite one of those. So pyvisit does does visit on that and arg. Basically this thing, right? So what can we do here? We can define a function that if we that calls pyclear, right? So we can do clear. That needs to have the same signature as this visit, so it will take a PyObject and an argument that's unused, right? And it will call pyclear on object, and it needs to return 0 so it doesn't like end the traverse, right? And now we can call traverse on this m with this clear function, and we don't need an argument, that's ignored here, right? And I hope that's the same thing as in this commit here. So there's this clear. Takes an object and a void argument, clears the object, returns 0. RPM module clear does one more thing before returning, and that's setting the mod state to null, so it can be reused. That's already nice. And then there's this free, which does the same thing if mod state still exists. Right? So let me just apply this commit. It's a bit better. And what's the this one?
Where is it?
Oh, there's some.
There's new code.
Yeah, there's code. We probably want the slots afterwards. All the pluses are in the right spots. Okay. And this might need a comment because it's not. It's a trick you don't really see in too much code. Okay, what do we want to do here? We want to do by clear on all the types in mod state, and right. Did that make sense?
Mm-hmm.
If I knew I was going to explain this to someone, I wouldn't use such magic, but here we are. GC callbacks. So these are GC callbacks. Again, whenever you malloc something, you need to free it. This doesn't quite free the mod state.
Yeah.
We should probably do that here, right? Well, eventually. So eventually we'll get rid of the malloc anyway, because we'll just tell Python to give us the space for the structure inside the module.
Okay.
Right now we have the mod state as a global pointer.
Will we then have to somehow free it, or will the machinery behind the module take
yeah,
care?
eventually the machinery behind the module will free it. So we should, free mod state here, well, before setting it to null, and also here.
Mm-hmm.
This should probably just call be a module clear at this point, because that's all it does. So this would be more correct. Hopefully it still works. Yep. Right, so let's free it. So because mod state is still a global static pointer, if we make multiple RPM modules, this malloc will overwrite that pointer, which is a pretty bad thing. So we should still have the only do this once guard still. And the next commits will fix that. What does this do? The proper API to get Python's runtime version was added to 3.11. On earlier versions, parses version info. It's process wide, as it should be usable in deinitializers, which can run after the module is garbage collected. Right, so, fun. So we probably want to support Python versions before 3.11. And that's 3 years back. I think it's still supported. Yeah. 3.9 is still supported by the Python core team, so 3.11 is now security only, but
I'm not sure how does like RPM work when it comes to integrating into Fedora, for example, like whether it everything that we are doing now will probably only get to the newer RPM, or maybe not.
well, so there's a symbol called PyVersion that was added in 3.11 that gives you the version of the currently running interpreter. Before that, we only had PyVersion hex, which is a compile time macro. So if you compile with Python 3.13, it'll give you 3.13, even if you later run on 3.11 or something like that. So PyVersion, that's the proper API to use. If you don't have it yet, you need to do this dance. So this calls PySysGetObject on version info, which imports the sys module or gets the sys module and gets version info from it. That's a tuple with the Python version number. You parse the tuple into 3 integers, a Python object, and another integer, and pack these 2 numbers into one value, right, to a long. Right. Let me quickly check PyArc parse tuple. What does it do with store a Python object? A new strong reference is not created, so this is fine. Okay. And then this does if Python version is 0, then it says then it sets it to Python version. If it's still 0, that means there was an exception, so re-raise the exception. Here, RPM system replacement for PyVersion from Python 3.11. Right, so hopefully this makes sense. So let's cherry pick that. And if we only support 3.11 and more, this can easily be updated to just use PyVersion. Right, next up, use the type allocation function. What does this thing do?
Yeah, I was looking at that.
This does PyObject new. PyObject new is a pretty low-level function. It allocates a new Python object, so it basically does a malloc, and it fills in the type, like the Python type, and the reference count, starting at 1, and that's it. That's all it does. There is also PyObject GCNew, which you just need to know about, which is like PyObject new, but it's for object with the PyTP flags have GC flag. And all of the types we're creating now have this flag, and you just have to magically know that if this flag is set or inherited, then if you use PyObject new, bad things will happen, because the GC header will not be allocated.
How do we know our objects have TP flags?
Yeah, that's a good question. I could really use some help improving this documentation. Just ask me, I'll tell you. We'll have GC. At least I think we have GC. Maybe we don't have GC. I don't know. Should I need to know? No, I should not. Because there's a better way to create objects than malloc memory for them and just fill in the object header. And that is using the type allocation function. So what this does is it gets the type object from the module state. It gets the slot called pytp_alloc, and it this is a function pointer, and then it calls that function and it'll allocate the object properly. So if it's a GC object, then it'll call the GC new. If it's not, then it'll call the normal new. And what is this PyType get slot? So it goes into the Python object structure that we looked at here, and this is a C structure that has TP_alloc here, right? So this could also be spelled as TP_alloc equals this in the new C syntax, right? So the C structure has a member called TP_alloc, right? But we're using the limited API, which is supposed to be stable, and in that API we don't want to expose this the layout of this structure, because it could change, right? So we could add something new inside here. Well, hopefully not, but we could, I don't know, change the size of one of these fields or add a new one or something like that. So this structure is not available. So we couldn't do something like well, let's cherry pick this and work on that. That's RPM files py. RPM files py. Let's see. So instead of the PyType get slot, wait, is this the same thing? Just looking at, probably. Okay, so instead of this, we could just get this type and get TP_alloc from it like this. Right, so so this would be exactly the same thing, right? So usually in normal code you would just see that. I call TP_alloc directly, but because we don't have this structure exposed, we cannot do we cannot get its field. So Python has a special function called PyType get slot, where you give it some number that identifies the TP-alloc member, and it'll give you the function, which you can then call. Right? Maybe we want to do like assert that the subtype alloc is not null, but if it would be null, something would be very broken, so let's not even do that. Right? So this will properly initialize the object. And also, this is subtype, which so this can be any type. This can be a subclass of the whatever type this is defined for, rpm.files. Right? If you inherit from rpm.files, you will probably get an object with the GC flag, even if it didn't have one already. So it's always better to use the alloc function for the type.
I must admit I'm completely lost in that change. Like, it came out of nowhere. It's a random file, and it's just...
Okay.
How did it happen?
Let's leave it for next time then.
Okay.
We're out of time. I don't know why it's here now. Oh, it's because we are converting to GC objects in the next commit. Ah. Right, the next commit adds the TP flags have GC flag. Okay, so let's revisit this next time.
Okay.
Should be good.
Works for me.
So I hope you learned something new. See you.